All right, guys, last video for the week. Wanted to take a look at some problems where we are solving quadratics by completing the squares and how to deal with what happens if our leading coefficient is not 1. Okay, now we did some problems similar to this yesterday. Okay, these guys right here, but there's a big difference here. Yesterday, we weren't trying to solve anything. We were just trying to create a perfect square trinomial and then come up with its factored form. Okay, so we couldn't just throw this GCF that we factored out, couldn't throw it away because it is part of the factored form of the answer. Okay, so here we're not solving anything. Okay, none of these are equations that we're trying to solve. We're just trying to factor. Okay, that's it. Okay, create a perfect square trinomial and then factor it accordingly. Okay, here it's different because now we're solving an equation, okay, which means that I can divide out that leading coefficient because I have an equation, an equal sign, two sides of an equation. I can divide all the way through using our division property of equality. So radically different than this, okay? We can't apply properties of equality here because we're not solving an equation. Okay, here we can apply properties of equality because we are solving an equation. Okay, so we take that first one, okay, 2x squared plus 14x minus 4 equals 0. Now, I want this leading coefficient to be 1 so I can use my process for solving by completing the square, which means I have to divide out that 2. So if I divide this by 2, that means I got to divide everything by 2 all the way across. Okay, and once again, I can apply the division property of equality here because I am solving an equation. Okay, so this ends up giving me x squared plus 7x minus 2 equals 0. Okay, so now we can solve by completing the square. Okay, so again, I want to keep this x squared and 7x together. And I know I'm going to have to come up with that missing constant term. Okay, now I want to get rid of this constant. I want to get it over to the other side. So if I move it over to the other side, I just change it from negative to positive. And then whatever I add to the left, I have to add to the right here. Okay, so let's see. We take our linear coefficient, we divide by 2, and then we square that. So I've got to add that over here as well. Okay, so let's see, I get x squared plus 7x plus, that would be 49 fourths equals 2 plus 49 fourths. Okay, so factor the left-hand side. It's a perfect square trinomial, so it factors into the square of a binomial. Bring the sign of the linear term down. Okay, square root of x squared is x. Square root of 49 fourths would be 7 halves. And then on the other side, let's see, that would be like 2 over 1. So I'd have to multiply above and below by 4. Okay, so I'm going to get 8 over 4 plus 49 over 4. And that gives me 57 over 4. Okay, take the square root of both sides. Once again, we take the square root of any positive number. We have a positive and a negative square root. Okay, so we get x plus 7 halves equals plus or minus. Okay, let's see, 57 is definitely not a perfect square, 4 is. Okay, so right here, I'm thinking that's like plus or minus square root of 57 over the square root of 4. Okay, so I know I can definitely take square root of 4 down below, and that's a 2. Okay, square root of 57, let's see. It's not a perfect square, but is it in simplest radical form? Okay, now if I look at 5 plus 7, that's 12. 12 is divisible by 3, so I know 57 is divisible by 3. So let's see, 57 divided by 3, that's 19. Okay, so if we look here, 57 equals 3 times 19. And notice both of those factors are prime. Okay, so there's nothing I can do as far as putting this in simplest radical form. It's already in simplest radical form. So we just get plus or minus radical 57 over 2. Okay, so I've got to subtract 7 halves from both sides, so I get a negative 7 halves plus or minus radical 57 over 2, and that'll take me to my two solutions. And obviously notice I'm getting a radical in my answer, so I know my answer is irrational. Okay, so one, we would have to go negative 7 halves plus radical 57 over 2, and notice that they have the same denominator, so we can combine them and just put it all over 2. So I get negative 7 plus radical 57 all over 2, and that is reduced. Okay, and then I would have to go negative 7 halves minus radical 57 over 2. So again, they have the same denominator. Okay, so I can put it all over 2, and so I'd have negative 7 minus radical 57 all over 2, and we have our two solutions. Okay, so we're good there. Let's go down to the second one. Okay, so notice I have that 3x squared plus 6x plus 15 equals 0. I want to divide out this 3, so I got to do it with everything. Okay, so I'm going to get x squared plus 2x plus 5 equals 0. Okay, so let's see. What are we going to do there? 3x, I divide by 3, divide by 3, divide by 3. Okay. All right, so I got to move this negative 5, or got to move this positive 5 over so it becomes negative 5. So I get x squared plus 2x plus some unknown equals negative 5 plus that unknown. Okay. All right, so let's see. What do I do here? Okay, I take the linear coefficient, I divide by 2, and I square that. So I have to add the same thing over here. Okay. Let's see. That'd be a 3x, that's x squared. That'd be a 2x, that's a 5, yeah. Okay, so let's see. I get x squared plus 2x plus 1 equals negative 5 plus 1. Okay, this is a perfect square trinomial. Factors into the square of a binomial. Bring the sign of the linear term down. Square root of x squared is x. Square root of 1 is 1. And on the other side, what do I have? Why do I have a negative 4 there? That's a negative 5. When I add them together, I get negative 4. That's a negative 5. Okay, so I get a negative 4 here. And we've got a problem, don't we? Okay? Because when I take the square root of both sides, and that's plus or minus, I've got a square root of a negative number, which takes us into the complex number system, okay, which some of you would know about if you had Algebra 2, and some of you would not. Okay, this right here, okay, we're only working in the real number system, okay, so this guy means we have no solution. Okay, because in the real number system, you can't take the square root of a negative number. Okay, now, for those of you that took Algebra 2, you did some work with complex numbers. You might have heard them called imaginary numbers. They're complex numbers. Okay, so you would probably be able to keep going, but if you haven't had Algebra 2, you wouldn't be able to keep going. So for our purposes, that just means we don't have a solution. Okay, we'll work a little bit with complex numbers when you come back to pre-calc, if you come back to pre-calc. Okay, so it is possible not to have a solution. Okay, so we're good there. Okay, let's see, we get down to that third one. Okay, I've got a negative 4x squared minus 16x minus 10 equals 0. I've got to divide out this negative 4. So I got to divide by negative 4 all the way through. Okay, so this will just give me x squared Notice negative divided by negative is a positive, so that would be positive 4x. Once again, negative divided by a negative is a positive. Notice that 4 does not divide evenly into 10, so we just reduce 10/4 down to 5/2. That's it. Okay, so I want to keep these two terms together. X squared plus 4x plus some unknown. Okay, I'm going to take this 5/2, move it to the other side, so it becomes a negative 5/2 plus whatever that unknown is. Okay, so let's see, what do we got to do here? Okay, we got to take the linear coefficient, we have to divide by 2 and then square that. So I have to add that same thing to the right-hand side. Okay, so I get x squared plus 4x plus, let's see, that would be 4 divided by 2 is 2, 2 squared is 4, equals negative 5/2 plus 4. Okay, so this guy factors into the square of a binomial, bring down the sign of the linear term. Square root of x squared is x, square root of 4 is 2, okay, and then we come over here and we say, okay, I've got to add these two guys, so that's like 4/1, so that'd be negative 5/2 plus, I got to multiply above and below here by 2, okay, so that would be 8/2, which obviously negative 5/2 plus 8/2, I get 3/2. Okay, so I get 3/2 here. Okay. All right, so we take the square roots of both sides, square root, plus or minus. Okay, so I get x plus 2 equals plus or minus the square root of 3/2. Okay, so this guy right here, okay, square root of 3/2, that would be the square root of 3 over the square root of 2. So I've got to rationalize this, multiply above and below by radical 2. So I'm going to get the square root of 6 all over 2. Okay, so I get x plus 2 equals plus or minus the square root of 6 all over 2. Okay, so I subtract 2 from both sides. So I get x equals negative 2 plus or minus radical 6 over 2. So this gives me my two solutions. So let's see, x equals negative 2 plus radical 6 over 2. And that is certainly one form of one solution. A lot of times, though, we would want to combine these, finding a common denominator. Okay, so the common denominator would be 2. So I'd have to multiply above and below by 2 here, so that would give me negative 4 plus radical 6. And that's usually how we would represent that solution. We would combine them. Okay, the other guy, I get x equals negative 2, minus, not plus, minus radical 6 over 2. Okay, so again, we would want to find a common denominator, and that common denominator obviously would be 2, so I'd have to multiply above and below here by 2. So we put it all over 2. So multiplying above by 2, that would give me negative 4 minus radical 6. Okay, and that would be the best form of our two solutions. Okay, so we're good there. Down to the last one. All right, let's see what's going on here. Okay, so I have this fourth one, negative x squared minus 5x plus 7 equals 0. So I've got to divide out this negative 1. So I got to divide everything by negative 1. Okay, so that gives me x squared. Negative divided by negative is positive, so that becomes positive 5x. Let's see, positive divided by negative is negative, so that becomes negative 7 equals 0. Okay, so keep the x squared and the 5x together. Move that negative 7 over so it becomes positive 7. Okay, now we solve by completing the square. So we take the linear coefficient, we divide by 2, and we square that. Add that same thing to the right-hand side. Okay, so I get x squared plus 5x plus, that would be 25 fourths equals 7 plus 25 fourths. Okay, factor this perfect square trinomial, factors into the square of a binomial. Bring the sign of the middle term down. Square root of x squared is x. Square root of 25 fourths would be 5 halves. Equals, let's see, I've got to add these two guys, so that's like 7 over 1. So I'd have 7 over 1 plus 25 over 4. So I got to multiply above and below by 4, so that would give me 28 fourths plus 25 fourths. So that's going to give me what, 53 fourths? Okay, so I get 53 fourths. Okay, take the square roots of both sides. And remember, that's plus or minus. Okay, so let's see, this guy right here, that's going to be like plus or minus the square root of 53 over the square root of 4. 53, I am pretty sure that's a prime number, so it just stays plus or minus the square root of 53 all over square root of 4 is 2. Okay, so I get x plus 5 halves equals plus or minus the square root of 53 all over 2. In this guy, we would subtract 5 halves from both sides. So I get a negative 5 halves plus or minus radical 53 over 2. And that takes us to our two solutions. Okay, so I would get x equals negative 5 halves plus radical 53 over 2. And obviously they have the same denominator, so I can just put it all over 2. So that'd be negative 5 plus radical 53. Okay, and then down here, I'd have to go negative 5 halves minus radical 53 over 2. Again, they have the same denominator, so I can just go negative 5 minus radical 53 all over 2, and it gives me my two solutions. Okay. All right, let's see. I have a couple more problems. I'm wondering if any of them are interesting. Maybe we'll try a couple more. Okay, let's see on this page. I don't know if we have to do all 4 of them. Okay, but let's try a couple of these. Let's see what looks interesting. What looks interesting? How about we'll try this guy here, see what happens, and then we will try, how about this guy here? We'll try those two. I don't think we have to do all 4 of them. We'll just get a couple more in here. We should be good. Okay, so that second one down. Okay, 2x squared plus 9x plus 4 equals 0. Okay, so we got to divide out the 2. Okay, so I end up with x squared plus, obviously 2 doesn't divide into 9, so we just get 9 halves x plus, this would be 2 equals 0. Okay, I want to keep the x squared and the 9 halves x together. I've got to figure out what do I put here. Okay, I take that 2, move it to the other side so it becomes negative. Okay. All right, so let's see. I have to take this guy, I have to divide by 2 and then square it. Okay, so let's do a little sidebar up here. I've got to take 9 halves, and I got to divide that whole thing by 2. So that's the same as 9 halves times the reciprocal of 2, which is 1/2. Okay, so notice I get 9 fourths. So when I divide by 2, I get 9 fourths, but then I have to square that. So I've got to add that over here. Okay. Okay, so let's see, we get x squared plus 9 halves x plus, let's see, when I square 9, I get 81, and when I square 4, I get 16. It's negative 2 plus, that would be 81 over 16. Okay. Right here, I'm going to have to add those two, finding a common denominator. Okay, this guy I got a factor. Factors into the square of a binomial. Bring down the sign of the middle term, so that's plus. Square root of x squared is x. The square root of 81/16 is 9/4. Okay. And let's see, this guy over here, notice I'm going to have to multiply above and below by 16. So that guy right there, when I multiply above and below by 16, I get a negative 32/16 plus 81/16. Now let's see, I want to make sure I don't get that wrong when I add them together. 81 minus 32. Okay, I'm getting 49/16. Now I like this guy because that's a perfect square. The reason it's a perfect square is the numerator and denominator are both perfect squares. Okay, so we take the square root of, okay, remember that's plus or minus. Okay, so I get x plus 9/4 equals plus or minus. Well, the square root of 49 is 7, and the square root of 16 is 4. So we like this guy because notice I'm not going to get irrational numbers. So I have to subtract 9/4 from both sides. So x equals negative 9/4 plus or minus 7/4, and that takes us to our two solutions. So let's see, our first solution would be a negative 9/4 plus 7/4. That would give us a negative 2/4, which is negative 1/2. Okay, so that's one of our solutions. The other guy, okay, x would be negative 9/4 minus 7/4. That would give us a negative 16/4, which gives us negative 4. And we've got our other solution. Okay, so got them there. We're good. Let's see, last problem for the week. Okay, let's see what we got. We said we're going to do that third one down. Okay, so we got number 3 here. Okay, negative 5x squared minus 20x minus 15 equals 0. Okay, divide out the negative 5. Divide everything by negative 5. Everything by negative 5. Okay, so let's see, that'll give us x squared. Negative divided by negative is positive, so that's plus 4x. Negative divided by negative is a positive, so that is plus 3. Okay. Keep the linear term, the quadratic and the linear term together. I've got to come up with my constant term. We bring this 3, we move it over, so it becomes negative 3. Okay, so let's see. We take the linear coefficient, we divide by 2, and we square that. Add that exact same thing over here. Okay, so I get x squared plus 4x plus 4 divided by 2 is 2. 2 squared is 4. Okay, so that's going to be negative 3 plus, once again, this is 4. Okay, things are going to turn out nice here. Okay, so let's see. We factor this guy. Okay, so it's going to factor into the square of a binomial because it's a perfect square. Okay, bring down the sign of the linear term. Square root of x squared is x. Square root of 4 is 2. On the other side, when we add these, we get 1. Oh, I like this guy. Okay, this is going to come out nice and clean. Take square root of both sides. Remember, that's plus or minus. Okay, so I get x plus 2 equals plus or minus. Square root of 1 is 1. Okay, so just subtract 2 from both sides. So x equals negative 2 plus or minus 1. And that takes us to our two solutions. Okay, so x would be negative 2 plus 1, which obviously gives us negative 1. There's one of our solutions. And x would be negative 2 minus 1, which is negative 3. That gives us our other solution. Okay, so that wraps it up for this week. That should be more than enough to help you out. The quiz was posted yesterday. Okay, so you got everything you need to get working on that. It's obviously due next Monday. You guys make sure you stay safe out there, and I miss you a whole bunch.